Welcome back. We're in week 13 and we're talking about wave properties. Today, we want you to be able to understand the idea of wavelength. Now, nobody really has such colorful eyes, although it would be kind of cool. The colors were added digitally after the photo was taken. They represent all the different colors of light. Light is a form of energy that travels in waves. Light is of different colors, has different wavelengths. Wavelength is one way to measure the size of waves. It is the distance between two corresponding points on adjacent waves, and it is usually measured in meters. How it is measured is a little different for transverse and longitudinal waves. With transverse waves, particles of the medium vibrate up and down at right angles to the direction of the wave. The wavelength of a transverse wave can be measured as the distance between two adjacent crests or high points, as shown here. In a longitudinal wave, particles of matter vibrate back and forth in the same direction as that of the wave. The wavelength of a longitudinal wave can be measured as the distance between two adjacent compressions. Remember, compressions are the places where particles of the medium crowd closely together as the energy of the wave passes through. The wavelength of a wave is related to the wave's energy. Short wavelengths have more energy than long wavelengths of the same amplitude. Remember, amplitude is the measurement of how far the particles of the medium move up and down or back and forth when a wave passes through them. If you forgot, feel free to go back to the previous video. You can see examples of transverse waves with shorter and longer wavelengths in this figure. So, quick question. Of all the colors of visible light, red has the longest wavelength and violet has the shortest wavelength. Which color of light has the greatest energy? Take a second and think about that for a second. Which wavelength has the greatest energy? Which color of light is it? What? Back already? Awesome. Let's get on to this answer. Which color of light has the greatest energy? Well, violet has the greatest energy because it has the shortest wavelength. So, in summary, wavelength is one way of measuring the size of waves. It is the distance between two corresponding points on adjacent waves, usually measured in meters. A wavelength of a transverse wave can be measured as the distance between two adjacent crests. The wavelength of a longitudinal wave can be measured as the distance between two adjacent compressions. Short wavelength waves have more energy than long wavelength waves of the same amplitude. So, if you can explain to me what a wavelength is and how it affects energy and measures various aspects of the wave, then you may move on to the next activity. Otherwise, please feel free to go back to the activity that we just saw, this video, and view it one more time. Thank you for being here. We'll see you soon.